Hello everyone, this is Niteen Mohod and today we are going to see Introduction to Phase Lock Loop, that is PLL. So far the history of phase lock loop is concerned, it emerged in early 1930s. At that time the developing cost of this technology was very high, and that is because of the lack of technological developments. But with the development of integrated circuits, PLL IC 565 became nowadays one of the main building blocks in the electronics technology. Today this IC available as a single IC in the SENE 560 series. SENE, these are actually the temperature designations which represents the military and commercial temperature ranges in which this IC can work safely. This 560 series is actually from 560, 561, 562, 564, 565 and up to 567. All these are phase lock loop ICs, but they are differ in some parameters and features. To reduce the buying cost further, discrete ICs are used to make PLL. Various PLL ICs can be differentiated through the parameters like, I'm talking about these ICs which are all PLL ICs, but they are differentiated through some parameters like operating frequency range, power supply requirements, frequency and bandwidth ranges. SENE 565 is the most popular version IC, which is available in 14-pin DIP, that is dual inline package, and 10-pin metal can package. Through diagram, if you want to see, we can see that this is the diagram of DIP package of IC 565, wherein you can clearly see pin number 10 and pin number 1, they are the supply pins, while pin number 2 and 3, they are the input pins. Pin number 4 is VCO output, that is voltage control oscillator output. Pin number 5 is phase comparator, VCO input. 6 is reference output, 7 is VCO control voltage. 8 is timing resistor, 9 is timing capacitor, while pin number 11 to 14, no connection is provided to these pins. So far the round metal can package is concerned, here only 10 pins are taken into account and these 4 pins are avoided which are having no connection. Otherwise the pin configuration is same. Pin configuration, I mean the importance of the pins from 1 to 10, they are same as in DIP. This phase lock loop is basically consists of 3 blocks, as you can see here: phase detector, VCO and amplifier. And here it's basically a closed loop feedback system. This is very important to know about PLL, that it's a closed loop feedback system with basic function is to lock the frequency and phase of the output signal to the frequency and phase of the input signal, where the input signal may be sinusoidal or digital. Use of PLL was limited to specialized measurements in the past, since constructing PLL with discrete components which was involving very complex circuitry, and it was resulting in the increase of cost. So in order that at that time the cost was the parameter because of the complex circuit, and it was a complex circuit because it is made out of discrete components. With the development of monolithic PLL, that is single crystal PLL circuit or PLL phase lock loop, you can say, it's more economic and reliable now. PLL is one of the most frequently used communication circuit, and it's possible due to availability in IC form. Here you can see the base block diagram of PLL, that is phase lock loop, where the first block is phase detector which receives input frequency Fin, then low pass filter, and thereafter the voltage control oscillator. This is the forward path as we have shown here, and from output, the output part of the output is fed to the input at the phase detector, where the phase detector receives 2 frequencies, F0, that is the output frequency, and Fin, that is the input frequencies. These 2 frequencies are compared and we are getting here the error voltage, and low pass filter avoids the high frequency noise and only allows the low frequency noise to pass, which is the input voltage for the voltage control oscillator. Accordingly you will get the F0. So this is how the block diagram of phase lock loop works. PLL mainly consists of phase detector, low pass filter and voltage control oscillator. Input signal with voltage Vi and frequency Fi is passed through the phase detector. Basically, it's a comparator which compares the two frequencies Fi and F0, that is the feedback frequency F0 or output frequency F0 with the input frequency Fin. Phase detector gives an output error voltage. Here you can see Fin plus F0 and Fin minus F0. These two parameters or two values you are getting because these two voltages are being compared with the phase detector, that is a comparator, and you are getting Fi plus minus F0, which is a DC voltage. This DC voltage on passing through low pass filter, it removes high frequency noise, that is Fin plus F0, and produces a steady DC level, that is Vf, that is Fi minus F0. Vf also represents the dynamic characteristics of PLL. The DC level is then passed on to VCO, that is voltage control oscillator. Output frequency of the voltage control oscillator, that is F0, is directly proportional to the input signal which it receives. Both the input and output frequencies are compared and adjusted through feedback loops until the output frequency equals the input frequency. Thus, PLL works in 3 stages: free running stage, capture stage and phase lock stage. Free running stage means when no input voltage is applied. That time the PLL is set to be work in free running stage or free running type, or it's called as a running in free running mode. Then on applying input frequency, VCO, that is voltage control oscillator, starts producing an output frequency for comparison. This stage is called as the capture stage, where the capturing of the frequency is done. Frequency comparison stops as soon as the output frequency becomes equal to the input frequency, and this stage is called as the phase lock stage. I think, or I hope rather, the idea of phase lock loop, it's IC 565, the different versions in the IC, their differentiation through different parameters, the block diagram of phase lock loop and its basic working is clear to you from these slides. Thank you.